You are welcome to today's class. We are still on set. Okay, consider the following. We're given the universe to be this. You can see all the elements present in the universe, and we're given the elements. We are given A, that is elements A. We can see all the elements present in A. This number, this one simply means number of elements in A. Number of elements in A, they are what? They are 4. If you count it, 1 2 3 4. So the number of elements in A are 4. For element B, they are 3. 1 2 3. You can see it here. For element C, they are what? They are 5. You can see it here. Now the question asks us to use Venn diagram to represent the above information and find the number of elements present in A union B union C. The first one is to draw our Venn diagram. We have to make use of Venn diagram. So we have elements A, element B, element C. These elements, this one simply means the universe. So we have 3 major elements here. For the elements A, let me draw the circle for the elements A. For element B, this element A, this element B. Why for element C? Okay. Now, what are those? Or is there any element that is common in A, B, and C? The element that is common in A, B, and C will occupy this space, because this space, if you trace it, is part of B. If you trace it, is part of C. And if you trace it, is part of what? A. So the element that is common in elements A, B, and C is what? We can see that 4 is here, 4 is here, 4 is here. So we have 4 here. Okay. Now, is there any element that is common in A and B? Let's look at element A. This element A, this element B. Is there any element that is common in both? Apart from 4. You know, this 4 is common in all of them. So I've already written the 4 here. So is there any other element that is common in A and B? Elements A and B. We see that there's no elements, so we leave it like that. This space simply represents element that is common in elements A and B. If you actually trace it, you see that it's part of B, it's part of A, but it is not part of what? C. It is only this space that represents the element that is common in A and B. So that one is nothing. Nothing is there. We leave it like that. Let's look at elements B and C. We have this element B, we have element C. Apart from 4, you know, we have already written 4. Is there any element that is common in B and C? Let's look at it. Is there another element again? That is B union C. We have 1 here, we don't have 1 here. We have 9 here, we have 9 here. So element that is common in B and C is what? Is 9. So I will put 9 here. What about elements A and C? A and C. Is there any element that is common in A and C? This A, this C. A and C. We have 2, no, 2 is not here. We have 4. 4 is now, apart from 4, leave 4. We have 6, we have 6, we have 8, we have 8. So the element that is common in A and C are what? 6 and 8. 6 and 8. So we have 6 and we also have what? 8. Okay, that's for that. What about the elements that are common in A? This A now. Now if you look at A now, what are those elements that are common in A? We have 2, 4, 6, 8. Okay, what I need to write here, they are what? 2, 4, 6, and 8. But I will not write, I will just write only 2 here. Why? Because if you trace this A part, if you trace it like this, you notice that we have already have 4, 6, and 8 as part of element A. You can see it. So the only one that is not there is what? 2. I need to write it 2 here. That's for that. Let's look at element B. Now in element B, we have 1, 4, and 9. Now if you trace this B side, you see that 4 and 9 is already here. It's part of it. So the only one we only add to it is what? The only one we need to add to it is 1. So I'll put the 1 here. What about element C? These are the elements present in C. 4, 6, 8, 9, and 15. Now among them, I've already have 6. If you trace this C part, if you trace it like this, you see that we already have 4, 6, 8, and 9. The only one that is not there is what? The only one that is not there is 15. So I'll put 15 here. Yes, this is our Venn diagram. But if you look at the universe, yes, is there any element in this universe that is not here? Let's figure out those elements. One is already exist here. Two is already exist here. Is there? Three is not here. Three is not here. So I will need to write it here. I can write it here. We have 3, comma. Is there any other element again? 4 is already here. 5 is not here, so we need to include 5. What about 6? 6 is here. This 6. 7, is there any 7 here? No, I will include 7. 8 is the next one. Is there any 8? Yes. 9, yes. And 15, yes. So this 3 elements here simply means element that is not part of A, that is not part of B, and it's also not part of what? Not part of C. Now, the next question. Now, this is our Venn diagram, right? So the next question is to find the number of elements present in A union B union C. First thing, we need to know A union B union C. So we need to know A union B union C. A union B union C simply means we combine all the elements here. We combine the elements in A, in B, in C. We combine all of them, and these are those elements here. Let's begin from the smallest. We have 1, we have 2, we have 3. Yeah, no. We have what? 4. We have 5. Do you have 5? No. 5 is not here. Do you have 6? 6 is here. Yes. Do you have 7? No. Do you have 8? Yes. Do you have 9? Yes. Do you have 10? No. 11? No. 12? No. The next one is what? 15. So A union B union C simply means we combine all the elements in A, B, and C. You can see this A, B, this B, this C. So all the elements present here, they are A union B union C. So now let's find the number of elements in A union B union C. They are what? How many number of elements that are present here? 1, 2, 3, 4, 5, 6, 7. 7. That is our answer to that. Stay tuned for more tutorial video. Do like to subscribe, like, comment, and share. See you in my next video.